Okay, folks. Hello, YouTubers. That's 81.6. That's a big boost converter off of a 36 volt power supply. I'm going to have to charge them. Okay, folks. Well, the bad news is I'm going to have to charge every one of these cells because, well, apparently I forgot to charge some of the cells and it pulled all cells down, and somehow I ended up with 1.5 volt. So after the cells are charged, I'll be back in. Okay, just wanted to go over. Let me turn my screen. Alright, just wanted to go over what I got going on here. This I use on my electric mid-size motorcycle that I built. Well, technically I bought, but I upgraded the entire driveline along with the battery. I use this. It's a 60 volt power supply rated at 20 amp according to China. Actually, if you keep it at 20 amp at 60 volt, you'll fry it. I've already done one, so yep, never again. Boost converter. I've got the same kind of boost converter in my bike. I use this to maintain the batteries, the lithium ion batteries in the house, off of a 12 volt lead acid. I've got a hybrid setup. I already had lead acid batteries, sealed glass, absorbed glass mat, AGM batteries, just put it that way. So I wanted to work up a way to do a hybrid system. Well, the only way you're going to get 15.9 volts out of a 12 volt battery is a boost converter. This boost converter will run 17 amp on the input 24/7, 24 hours a day, 7 days a week, year round. Done it, proved it. It's the way I've got it built. It's good heat dissipation, and it's no problem. Right now it's hitting 18 amp. I'm not stressing that on the input. That's why they do double wires, people. If you guys ever, any of you ever get any of these, make sure to do the double wires. 14 gauge wire would be good enough. And then do 12 gauge or maybe 10 on the outputs. That'll reduce your voltage drop. But 12 will be acceptable because you're only doing about 18 amp. If you go over 20 amp on these, they will pop the MOSFET. As soon as you plug it up, the current spikes way up and drops back down pretty rapid. So that's your surge current. I've seen them go up to 100 amp and pop the MOSFET. 50 amp, pop the MOSFET. So you got to keep it below 20 amp. 17 amp, I know they're good and solid. 18 amp with this thermal setup, they're okay. The inductor, it's getting almost can't touch hot. Fan on the bottom, kind of overkill, but I wanted to make sure that it stayed cool. And I've also got a thermal pad underneath the board itself, so any heat that builds up can go to the block. When they sell these on Amazon, they are not thermally correct. there's not enough. Absolutely not enough. I've got a voltage regulator board to control the fan because of the varying in voltage. But I'll always monitor these by the input. If I want to know what it's doing on the output, then I'll move the meter. But the biggest thing is setting 17, 18 amp on the input at most. This will take about 4 hours to charge these batteries. And when that's done, I guess I'll find out how my setup's going to work, because all the other cells except for this one will be charged, which means that's going to fall back on the top charge. And I'll also find out what these active balance boards can really do instead of going by factory. I'm showing 81.8 volts overall. That's because they're being charged. Balance is turned on, which means it'll randomly hit 1 amp balance to go to other cells. So, what's the timestamp? I think it's going to be about 3 or 4 hours before these are actually fully charged. I'll just keep an eyeball on them. Step out maybe in a couple hours, but and check on them. But it's going to take a bit. I think some batteries in this section were actually not fully charged. I did the best I could. I tried to charge every battery after I capacity tested, but somehow I missed some. And it probably wouldn't be a bad idea to go ahead and charge the others, but that's just more time. I was hoping to be able to start this car today, but looks like that's not going to happen. So until these batteries are done, people, I'll see you in the next catch. Okay, I'm back, and the timestamp's right, 3:18. So, it's been a few hours. According to my meter, it's still doing the output voltage, so that means that didn't blow up. But it's showing 0 current, and that's actually a little concerning. So, let's first off, oh, I'm getting shocked. Yes, that's me. Not that I don't mind getting shocked, but 20 volts ain't gonna cut it. Just want to make sure the boost is still doing an output voltage. It is 82.2. That's fine. Getting shocked again. Ow. Alright. Give the getting shocked a break. When the green blink, that's an indication that it's actually balancing. Move this out of the way. And of course I'm taking a sneak peek over top of the camera. Zoom that in. Looks like all 5 Bluetooth are coming up. Eleven BCA, active balance. Hold on just a minute. Now I'm not really sure if that's going to show up clear or not, but these are all showing 3.2, almost 3.3, and the one I was having trouble with is ending in 2165. Number one showing 3.345 volts, and this one is the one that was showing 0. Well, it said it dropped down to 0. In fact, I suppose 2.3 volts is borderline for the Bluetooth to even function when all the cell voltage is down that low. That's the only thing I can figure with that. So if I ever get a Bluetooth that just will not show up even after I've hit the button, and yes, sometimes on occasion you do have to hit the button. I'm glad to see that all these batteries are charged. I don't want to fully charge them because I want the car charging system to do its thing. Where's 11D57? It's grayed out. In order to see the voltage, I've got to enter the pin in every single time. BCA. 2165 I've already looked at. 204 AD, I think that is one of the bottom rack. $204 AD. No, that's okay. That's the top rack. That's the middle one. That's the one that had the cold solder connection. I'm standing right next to this camera, and the microphone is pretty sensitive, so if it gets too loud, I do apologize. All the cells are reading okay. I actually charged them up to 3.4 volts, I believe. So they balanced out between each other. 2165 is blinking, so $11D401. Let's see what that one's doing. Balance is off. Now, when they do active balance, they will not stay constant at 1 amp. They'll turn on for maybe 60 seconds and shut off. Those boards do get warm when they do active balance. I did check for that. But you got, where is the temperature? Right there. Nope. Number 110.40C. So you can, as long as these are attached to the cells, you can see the temperature of the cells by the radiation, the heat radiation. Go back in 2165, and I want to see if balance is on. Balance is still showing on. Okay. Looks like to me I'm all good to put this battery in place. People, that footage on that software was absolutely horrible. I'm sitting here watching it, doing edit right now. 2165 is grayed out. Is there anything? Well, there's 20. The 0E6E is actually going to be the part of the 32S for the Saturn. We'll add. Be my luck, it's not going to add because I'm actually sitting inside the house. Where's 1157? 11 BCA. Okay, 204 AD. That's the 4S one.
I put it in the middle. I thought it'd be better off for it to be in the center than instead of the very end on the ground side or positive. Um, Not really sure why. Maybe it's because your biggest discharge and charge is going to be on the end. And it would help as far as balancing goes on active balance to have more cells to work with than just 4. So that was my thinking on that. Let's see if we can actually find one of the 24. Nope, that's a 16. Um, this is one of the 16S batteries that I'm going to be using for the Saturn. It's a perfect example for the car. I just got off work probably about 45 minutes ago. I'm sitting here eating while I'm editing. I seen the footage on that software and I was like, oh my god, that's horrible. Um, there is a point where I've got to enter a password in. I will cut that part out. You do have to enter a password in to get to this point. Believe me, the last thing you want is somebody to get in and start messing with your settings. For lithium ion, these are okay to leave at their factory default. That's 3.3 volts for it to start. And you figure 3 volts is considered mostly dead. I mean, to be honest, dead is 2.8 volts. Don't use it anymore. But 3 volts puts a cushion in there for not completely discharging the cell. And for 2.3 volts, well, 2 volts is dead for LiPo 4. So that's why I did the 2.3 volts for these cells. I may bump it up to 2.5. Sorry about that. But, yeah, I don't know yet. I need to see what the car is going to do with the charge when I get it started. And with all the voltage being at what it is now, it's definitely going to want to charge. If I full charge these batteries and it picks it up right away, I'm not going to know what the charging system is as far as top voltage until the cells are discharged. That's why I'm starting them out at 3.2 volts. I did not fully charge all the cells on purpose. Because I want to see what the top end voltage is on this charging system. If it's 380 volts, I can't use these cells, and that'll be, well, about $1,200 wasted. So active balance, to give you a perfect example, this is what the screen looks like. I do have to hit a password, and like I said, occasionally you do have to hit the Bluetooth button on the module itself to get it to come up. Main interface, that puts you back to here. That gives you the sum voltage of everything that's linked. .2165 is grayed out. Let's see, what was E6E? 68. .2040. Oh, I think that was the 4S. Yeah, that's the 4S. Back to the main interface. Well, if it'll let me. Series, because, well, these cells are all in series. Let's see if I can get to 2165 to come up. Nope. Too far away. 11D41. I think that one was the one that was the problem child. Let's see what's up with it. Look at that. All of them's 2.3 volts. Kind of the mid-range 2.3. Well, 2.2, 3, 2, 4. And that's pretty typical. At least none of them's dead. That number 1 cell, hopefully it's not hurt. But only time will tell. Okay, people, this is all I wanted to show you, give you a good idea on what's up with this software, because the footage that I took on here is horrible. And now, back to the show. Upside down picture, but what can you do? It's 2165. I just want to make sure that these other two are okay. The 4S is definitely okay. The one not to pick is 11D57 and 11D. And folks, I have no idea what happened. I checked all the cells in this top rack a few days ago, and it was perfectly fine. Maybe it was the moving it around that agitated it. But who knows? But I have already irritated my back trying to put this top rack in and out. And this is what I was talking about yesterday in my last video. Well, yesterday's video, which is today's video of you guys, because I'm going to combine everything in. And I'm going to just put it in and see what happens. That's all I can do. But if I end up having a problem after I put this thing in, I'm walking away. I will not mess with it for the rest of the day. This battery is a bit on the heavy side, and it's got to be manhandled. Stupid mosquitoes. How can I do this without doing the final step of hurting my back? Wrong one. Oh, Lordy. Oh! Yes, I just...
Check, check, and recheck. Eleven D57. Bottom rack. Bottom rack, okay. 3.2 volts. That's Bluetooth 1. $11D41. Bottom rack, last Bluetooth. All cells 3.2. Bottom rack, okay. Top rack. Two zero 480. That's 4S. It's okay. 3.2 volts. No, 3.3. DCA. All the cells are good. That's Bluetooth 2, top rack. And then the 2165. They're all 3.3. Now I can move forward. On wiring to the car. Okay. Gotta find the ground wire to run from battery ground over to battery ground input. I'm showing overall voltage is calculated at 330 volts. 330 volts. That's pretty much normal. Max charge is going to be up around 365, I think, for the car, according to the nickel metal hydride batteries. I've got to see what the car tries to charge these batteries at. And I hope it is not above what this battery can handle. If so, it's going to be a problem. But then on factory standard, to go along with that, they're only going to charge 90% of max voltage under normal circumstances. Alright, I've already got my service disconnect wires tied in. My positive cable and ground cable for output needs to be made. I didn't already make it. Okay, I'm going to get things sorted out here. I'll be back, but it'll only be a second to you guys to do video editing. Probably be a good idea for me to go ahead and charge all these batteries because they have been sitting for a while. Alright, I'm back. See, the camera's down to 2 bars now. Took me a bit to get everything sorted out, and I had to put that boost converter back on my batteries for charging, solar charging. Because I've got the my mid-sized motorcycle. I've got for the electric one. The building is actually hooked up to solar. That thing uses quite a bit of power to get the battery charged. It's about 80%, so it won't take but a few hours to get it finished topped off. I'm out of pieces and bits on 4-gauge line, which is what I did for, well, looks like I got lucky and made two cables. Out of the 4-gauge line that I had left, and that was for positive and ground. One I already had made, and I had to make the positive for this one. So ground has to go from over here down this way and connect over here, and that's going to be the top cell. And to verify that, I can step in the building on the original battery. Yes, definite. Bottom connector is battery positive for the car. Okay, cutters. I had to dig into my Saturn stash for the wire. This wire I'm planning on putting the 16S cells in series. I'm not going to be using much, so it shouldn't be any problem. Alright, make this ground. I really didn't want to dig into the Saturn stash for this because it's built differently. This is my work car. Oh, damn it. I'm always getting shot. This is annoying. Ow! Top post, top rack for battery ground. I'm gonna need a few inches longer. power gauge. Windy Nation Power Flex Welding and Battery Cable, 600 volts, 50 to 105C, made in the USA. Well, okay. You say so. I forgot to bring my crimper out. 4 gauge line. I do believe it's more like 6. Boy, I tell you what, the cable that I put in is 4 gauge, and it was actually too big. But it's got a low temperature skin on it, and it's not rated for welding. Boy, is this skin gonna cut or what? Jeez. Oh, it's double wrapped. Okay. I forgot to get my crimper, and I might as well grab my utility knife while I'm in here. Yeah, I was trying to set it where you guys could see a little bit up in here. Note to self, cable will not stay in the socket when you try to crimp it. Alright. Channel locks, your turn. Just in case anybody's wondering, I actually put tape across the connectors to try and help keep me from getting shocked. I don't want this cable being the highest point, so I guess I'm gonna have to run it underneath. Oh shit. The foam is in the way. Boy, this stuff is tough. My utility knife don't even want to cut through this skin. I've never bought welding cable before. I just bought 4 gauge power rated wire. This skin is tough. Let's see, it's got to be that way, and then this way. And that squeezes it in even tighter. Okay. Man, that tool might get along okay. It ain't pulling apart. I've always had the worst luck trying to do crimping type terminals. Do not connect to battery until you have a path. Neighbors are grilling. That's just making me hungry. I'd really like to start this car today. gonna have to turn this cable flat and then loop it. So that should be good enough. Oh, wait. I did make a cable for that positive. Oh, nice. Okay. Let's see. Looks like to me I can run that right through the standoff outside the foam, maybe through the standoff again and up, turn it up. Be nice if I could use the factory stuff, the factory connectors that go to this thing. But for some weird reason, let's see, this one goes to the top. Huh, that goes that way. Which way does this one turn? This way. And it puts it going the opposite direction. I don't understand that. Unless it goes to the service disconnect. Oh Lord, that's just too much. Okay, let's do something different here. Alright, I'm gonna edit this footage for today. I have got the service disconnect hooked up, and also the output lines going to the car. So next I've got to put in all the Ford electronics, hook up the cables that's supposed to be hooked up to the battery, and see what happens. Who knows? But I'm done for the day. As you can see the timestamp, it's 7:16. I'm getting hungry, and I've irritated my back with that top shelf battery. So I'm going to have to take a break. And yeah, depending on how work goes, I'm officially by myself now. My co-worker quit, and we've only got 2 guys to run Dell Repairs for the Lexington region, and it's big. We've got one place that we've got to go to. It's about 2.5 hours south, out in the middle of nowhere, right next to the Tennessee line. I don't have to go that far all the time. Sometimes I get lucky, get a schedule, and a bunch of people reschedule. As long as I get over 4 hours, I'm golden. I can still get 8 hours, so that's a perk for being full time. So I want to thank everybody that's actually watched this video, and if you're watching the video because you've had a vehicle like this in the past and you wondered, is it possible? My theory on it is all electronics do not care where the power comes from as long as it gets it to work. The things that you have to be concerned about is the voltage and the charging tolerance. So nickel metal hydride and LiFePO 4, they are both very comparable, and LiFePO 4 is also comparable to lead acid. The 4 cells together run 14.6 volts, so that's 14.6 at full charge. And then there's 50 modules like that in that car. And as far as voltage goes, I might be, well, let me calculate. 7.4. 7.4 volts times 50 modules. That's 370 volts. And then 14.6 volts times 50 modules. Wait, 25 modules. 14.6 times 25 modules. That's 4S. 25 4S modules. That's 365 volts. Now, on these hybrid cars, factory, for the life of the battery, will never charge batteries 100%. It'll always be anywhere between 90 and 95%. Now, within that tolerance level, that's going to put it very comparable to 365. And according to everything that I've read, the voltage is actually rated at 360 volts. The next thing to be concerned about is what the car, and this is what I'm going to have to test for, is what the car actually tries to charge the batteries to. If that's over 365, then there might be an issue. Of course, I've got the top balance and also the active balance boards together. But anyway, I'm blabbing. I'm going to run. There's going to be another video. I'll do another one later. And this one, I know it was long. I'll let the camera run. I'll do a bunch of cuts and stuff. There's scenes where I had to leave to go get stuff, and then the last part, camera got full, SD card full. So I had to come in and get all of it dumped into my computer and get it added. I'll do this video too as a close. Thank you guys for watching. Appreciate it, and I hope you find it interesting, at least. Or, you know, like I said, if anybody is wondering if this is possible, yes, it is. You don't have to spend thousands of dollars from a factory on a factory battery. Like I said, electronics don't care where the power comes from as long as it gets it to work. And it's within its voltage range. But anyway, you people have a good day or good night, whatever time it is you might watch this video, and I'll catch you next time.